Okay, so welcome to this session on JavaScript 2. We're going to be going through three topics in particular, and then we'll also do some Q&A. I have Discord chat open, so if you want to pop questions in the chat box, I can see those. I'm going to try and show a realistic example rather than doing like a very abstract example. And I'm hopefully going to try and show how these three things can be used together. They don't have to be separate concepts. They can actually complement each other and be used together. So yeah, I see another comment for reduce. Maybe we will do reduce. Okay, reduce is quite tricky, so we'll do that on its own. I think maybe map, filter, and sort would be a good group to get to if we have some time. Apologies about my voice. I've had flu over the weekend, so I've just recovered from that, but I'm still a little bit croaky. All right, so I just want to show you the project I've been setting up prior to this session. As always with these sessions, I have used Bootstrap. The reason I've used Bootstrap is because it allows me to get things set up very, very quickly, and I don't really have to worry about spending any time in CSS. I really enjoyed doing CSS, but at this point in time, we're talking about JavaScript. We don't want too much CSS getting in our way. We just want it to look presentable and to function properly. So this is all hard coded in HTML. None of this is dynamic. These buttons don't do anything. And there's actually 4 pages. So I've got store, I have cart, I have orders, and I have the profile. I actually have one more, which I don't have a link to, which is, I think, auth. So I've got an authenticate. None of these things do anything, right? These are all just, this is like your CSS frameworks submission. There's no JavaScript driving user interaction at all here. So that's what we're going to be doing in this session. I've intentionally chosen a project that's a little bit different from what you're going to be tackling in your CA. So we're going to be handling products. We're going to be handling items in a basket. We're going to be handling a sort of fake checkout process and a process of creating orders. I won't be using an API. But what I'm going to do is I'm going to create a fake API, and that's how I'm going to show promises, which was also on this list here. So I'm going to put that in there, promises. So this part of this session is going to be covered by me creating something that sort of behaves like an API, but it's actually all happening inside JavaScript. In terms of my HTML structure, I'm going to not spend too much time talking about this, but you may see that all of my HTML files are nested in folders, and they're all called index.html. For anyone who doesn't know, that means that you can have nice URLs like profile instead of profile.html. And you can also nest these folders, so you can have profile cart and so on and so forth. You might need to have settings, account, payments, add method, like something like this. And the way you achieve this kind of URL structure is simply by structuring your folders like this. So that's not really part of the JS2 session, but it's something that's quite often misunderstood. And if anyone's wondering why they're all called index.html, when I'm writing a project, every single HTML file is called index.html. Okay, so beyond the HTML structure, I have some empty folders. So inside source, this should actually be, I should actually have a JS folder there, And I'm just going to quickly move that stuff inside because that's where it was meant to be. There we go. Okay, so I have source, and this might also have my SCSS folder, but I am not using SCSS, so I'm just going to say index.scss and say I'm not using this file. But in theory, you'd have a style pipeline with SCSS there. So we have JS, we have our index file, which is blank, and then we have an empty folder called storage. We have an empty folder called API auth and API products. So this is something I like to do when I am starting off a project, and this is called scaffolding. So before you've actually written any code, you have hopefully done some planning, and based on that planning, you know which kinds of functionalities you're going to require. So for example, an e-commerce website is going to require some sort of API functionality to get products and to maybe update products or to purchase a group of products together. So in your plan, you write these things down, and when it comes to scaffolding, you've got to think, what's the best, how can I arrange these things in sensible groups where I don't have to spend too long hunting around my project files to find the code that I need. And I find lots of folders nested inside each other with small JavaScript files in a modular fashion is the easiest way to go. So that's what I'm going to show you. Did we also have storage in here? I don't actually know if, I'm just going to check the channel because I have a feeling that someone suggested storage. No. Okay, well we need storage anyway because we're doing a cart example. So I'm going to start there. I like starting with storage because it's a really neat little module that is often the same. So what do I mean by often the same? There's not that much variation between one developer's approach and another. If you ask 100 developers to write you a local storage module, they're all almost going to write you the same thing. The variation is very small. So this is something that I almost know by heart by now. So when we're writing modular JS, we are thinking about packaging functions together under one name. So that's why it makes sense to have these folder names, because everything inside this folder called storage, I want that to be part of my storage module. And the index file is the sort of entry point to this module. But obviously there's nothing here, it's useless. So we create the first file, and I'm going to call this save. So storage, save. So the job of this file is to export a function called save, and that's going to interact with local storage. In this case, we have a key, and we have the data or the state. State might be a bit of an unusual word to read in this situation, but it just means data it just means data pretty much. So we're expecting that the key is going to be a string, and the state could be really anything, because we want to be able to save anything. If you're using local storage dot set item with key, you can't save like an object. You can't save an array. You can't save, like, there's lots of things that you cannot pass directly into local storage. So that's why we have a little function to help us here. So I actually told Copilot to turn off. There we go. So in this function, we're going to serialize. I am just going to close this file. I don't want Copilot on, and it's bugging me. Let's see if that's made it go away. No, it has not. Okay. So you don't have to call your variable this, but I would call this serialized state. Serialized means turned into a string, effectively. Stringify state. And then you are going to set the item with the key and the serialized state. So there we have one function doing one task in one file. This is the heart of modular JS. It's very different from function make my page, where you then have lots of stuff going on. You might have a response from an API, and you might have some in HTML being created, and you might have some add event listeners going on, and then you might be doing some other things. This is too much stuff for one function to be taken care of. So we like our functions to be small, simple, and have one responsibility. And now that I have this save function, I'm going to, actually no, I'll get there at the end. So I need to clearly do the same thing for load, and I need to do the same thing for remove. And I might do one for clear just to be safe. So load, you're just going to be requiring a key. And here we need a try catch block, because this process is not guaranteed to succeed. There's certain cases where this will throw an error. So we're going to get our state, or our serialized state, from local storage, get item key, and then we're going to return json.parse and then the serialized content. There is a chance that this serialized state variable might not be something that JSON can actually manage. So there is a chance that this line throws an error, and we want to catch that error, because otherwise that's going to break the application. So if, for example, if we try and load a key that doesn't exist, it's going to return undefined. And if we can show this in the browser. So if I open the console, make this a bit bigger. So if I say json.parse undefined, it throws an error, because undefined is not valid JSON. Since we're looking at local storage and we're asking for a key, there is absolutely no guarantee that that key is actually going to be present. So if I was to run some code looking for a key that doesn't exist, the answer I'm going to get is undefined. And if I'm then trying to parse undefined, that's going to throw an error. So we have a catch block. What's the sensible thing to do in the catch block? Catch block is to return undefined. We could also return null, but in this case we're saying go and load this thing, go and load, like we would use it like load token, like that. And if there's no such thing as token in here, in local storage, then we're going to get undefined in the same way that a variable that hasn't been defined is also going to be undefined. So that's just a sensible behavior for this function. We're also exporting this just like we are exporting the save function. And then for remove, this is very easy. So export remove, export function remove key, which is same thing, just a string. And we can just say local storage dot remove. And there's a shorter way, there's a way to refactor that even more, but I'm not going down that avenue right now. That's fine. And clear is going to be very similar. So export function clear, and we're just going to say local storage.clear. Right, so each of these files is a module on its own, but I want something that's going to be like storage.save, storage.load, storage.remove, etc. That's how I want it to present itself in usage when we're actually using these things. So inside the index file represents the contents of its folder. So whatever's in the folder, it's the job of the index file to sort of package all of that up and make it a nice consumable bit of software. So in this case, we're going to export default, and we're going to export an object, and the contents of that object are going to be the functions that we have just written. So we've got save from save. We've got remove, clear, and load. And all I'm going to do is list these as items in the array. So I'm using shorthand object syntax here. So I could just say save, save, remove, remove, clear, clear, but we don't have to do that. JavaScript will do that for us. So here we have our module. It's not big. Each of these files is very, very easy to understand. If something goes wrong, there's only so much that can be responsible. So if you get an error saying error in save, okay, well, you know there's only 4 lines of code, actually only 3 lines of code that are even relevant. So it's going to be one of these 3 lines of code where the problem is, and it's probably going to tell you, the error message will also tell you which line it occurred on. So getting an error message that there's a syntax error in save.js, function save on line 2, it couldn't be any more clear what's gone wrong or what needs to change. If you have this gigantic JavaScript file with 450 lines and you get an error, it's going to say error in myscript.js line 452. That's going to be much more difficult to debug. Just to address some questions here. So yeah, what is load for? So yeah, these functions are meant to extend local storage to allow us to store objects. So local storage can only store strings. And so when we want to store an array or an object, we have to first encode that array or object into a string. Then we save it. And when we want to use that data, we have to unencode it. And the way that we encode is with JSON.stringify, and the way that we unencode or decode is with JSON.parse. All right. So at this point, it's a pretty nice time to make a commit. I have all of these files, they're all related to each other. So I might say add storage handlers. So that's the first little module done. And now we can test it in our index file. So I think I need to update the URL there. And I also want to say defer. So in the main file, our top level, so if I close these, you can see that there's one index.js file for the JS folder, and that represents the entry point to all of this code. So this file is responsible for the whole story that's going to unfold in JavaScript for the user. And that's why it's the only one referenced in HTML. So here we can import storage from storage index.js. And because this is a default export, We haven't actually named this anything, so we could call this like hamburger if we really wanted to. But it makes sense either calling it store or storage, because that's what it is, coming from the storage folder. And here we can test some stuff by saying storage.save and then example, and let's save an array of 1, 2, 3. So in my not found, oh right, I only corrected the home page. I need to correct the other pages too. So this is one of the annoying things with working with static HTML, is when you make one change, you've got to change it everywhere. In that situation, I use find and replace to make sure that I can get them all in one go. Okay, there we go. Does have an export named clear? Oh, did I not? I think I think I did this file. Yeah, I didn't change these. There we go. Okay, so let's add some console logging here just to make us feel at home. Okay, so we're going to test local storage functions. So we can see at least that test is running. We go into application, we have example, we have our array 1, 2, 3, so that's working. So we can say save is working. Now we can, well, let's do save function. We can take this whole thing and let's save delete me. And let's try an object this time. So we're going to save, and then we're going to remove. But we're going to check in the middle that it worked, right? So we're saving it, and if we delete it immediately afterwards, it will be like we can't necessarily know that it's saved in the first place. So I'm going to say storage.load, delete me, just to check that we actually have a value in the middle, and we'll hold off on that one. So this test here, I'm saving a key with an object. I'm logging the value of that object, and then I'm going to remove that object again. So we should see please delete in the console, and in the application storage panel, please delete has been deleted. So I can say delete is working. Or actually, this remove, I should say, but we'll leave it as delete for now. And we've also tested this inadvertently because it gave us the right value there. So the only thing to test is storage.clear. And if that works, then we should see nothing in local storage. So we've tested all parts of the module here. I'm happy that it's working. So this stuff can go, and I'm just going to comment out this import because I don't need it right now. I'll need it in the future, but right now I'm okay. I had one bug. So whilst I was working, after I committed, I found that one bug, which was correcting the links here. So I need to commit that, and I'm going to say fixes an issue with pathing, or pathing as in file paths. We also have some commits which are fixing links here. So all of the HTML files, that's also going to be fixes links with pathing. These files I'm not going to commit, or it's just going to be an unused file. This one I'm going to add to the git ignore. So there we go. And then this is this index.js file. This is sort of where we're working right now. So I'm not going to commit that. But I'm happy that right now, if I wanted to stop my project and finish for the evening because it's 12:30, do whatever, or if my house starts burning down and I need to pack up my computer and run out the building, I know that all of my work has been saved. And not only do I know that my work has been saved, I know that it's actually working, that the code is working. So I'm not going to resume where I left off last time with errors. Okay, so that's covered a little bit of modular JS. So let's go on and do some destructuring, and I think I'm going to do these three together, or maybe these two together. So I think, yeah, I think I will move destructuring down the list a little bit, and we'll do classes and promises next. So where would be a good class to start with? Well, I think the product class might be quite a good one. It's possible to have an auth class as well, so we could do that. But I do want to I want to make this little fake API. So I'm going to make a new file. Actually, I'm going to make a new folder called service, and this is where I'm going to create my mock API. So how do I create a mock API? It needs to return data after some time, right? Like that's the fundamental thing about an API, is that it doesn't happen instantaneously. You have to wait about 30 to 80 milliseconds before your data comes in. And the way computers work is they like to just continue executing one thing after another. They don't really have a concept of time in the same way we do. So asynchronous tasks can be very challenging. So I'm going to create a fake asynchronous API. I could use a real API, but this is going to demonstrate some of the things that have been requested so far. All right, so I'm going to start off by writing class, and I'm going to call this Ecommerce API. Let's just call it Ecommerce. Or I could, yeah, that's fine. It doesn't, I think that'll be fine. So the most important thing about a class is the constructor. And constructor is a bit of a long word for what it is, but if you think about maybe you've used new form data before, or you've used maybe new image, or maybe even new array. These are all classes. I'm trying to think of a better example than this, but my brain's not quite working correctly. So if you've run into anything like this whilst doing other JavaScript stuff, that's because it's a class. And there's two ways of knowing that this is a class. Well, I suppose three ways, because it's green. The new keyword the capital letter at the beginning of the variable name, those are the two things that tell you that this is a class. Classes are a huge part of programming. They're very, very useful, but it also takes a bit of a change in the way you think about organizing your code. Like I think with JavaScript, the temptation is to have a sort of very wide array of independent functions, and that's actually called functional programming, and that's not necessarily a bad thing. That's just a certain paradigm. With class-based programming, you're trying to group functions together, group data together to represent something like something real. So that's why often in examples it will be like class animal, animal, because an animal has things that we know we can describe about it. So it has legs, right? It has arms, it has teeth, it has a color, it has a continent that it lives in. It has, these are all different things about the animal. And in outside of computing, class means the exact same thing. So a class of vehicles, right? Like a heavy goods vehicle is a class of vehicles, and a dog is a class of mammal, and that sort of thing. So whenever we see these words in computing, they mean the exact same thing as they mean outside of computing. The weird part is that we're not used to being the ones who decide what is and isn't a class of something. Usually that's like university professors deciding these things, not us. So the challenge is the job of trying to like pull it all together into something that makes sense. And having delivered that speech, I now have serious concerns about the name of my class. So I'm going to call this store, or shop is even better, because store could be confused for something else. So this is my shop. What does my shop do? What do I need to create my shop? So for example, if I wanted to create a new shop and I wanted the currency to be krona, then in here I would have to have a field called currency, and then I can use that. I can say this dot currency equals currency. As it happens, I probably am going to have that as in my constructor. I probably want to have products in my constructor as well, because if I'm setting up a new shop, it's pretty important that that shop has products, and this is probably the best place to provide those products. And because it's products with an S, it's going to be an array, and a product is probably going to be an object. So for now, we can just leave it as an empty array. And I think I'm happy with that for my constructor for now. That's all the data that I want to accept in order to create my shop. But the shop doesn't do anything right now. It's just a shop that lets you look at products. And there's an empty list of products, so it's not very satisfying to visit at this point. All right, since we have a class called shop, and since we're going to be passing that class products, it makes quite a lot of sense to have a class called product as well. And in the constructor for product, we are going to want a few things that are also sort of common sense. So what's the important thing about the product? Well, its name, maybe the manufacturer. Yes, this is an Apple made by Samsung. The price, and anything else that might be relevant, a tag or on sale or whatnot. But let's leave it there. So we're going to go with a Samsung phone for 3,000 NOK. Okay. So I'm just writing this out. I like to write this first because then I know what to put in my constructor. So now I know that the first value in the constructor, the first argument in the constructor is going to be name. The next one is going to be brand, and the next one is going to be price. And I can say this.name equals name, this.brand equals brand, and this.price equals price. It seems a little bit redundant doing that, but it is the way it goes. There is a shorter way of doing it when you reach TypeScript, but for now, this is just how it works. Okay, so I can now create a Samsung phone by saying new product, phone Samsung 3000. And if I create a couple of these, I'll make an Apple phone, change this to Apple, make it 10 times more expensive, and we'll go with, I'm not going to do Huawei because I don't know how to spell that, Oppo, and we'll make it 330 krona. Okay. So we have our three products. Now we can create a phone shop. New shop. And we're going to set that as our currency. And we're going to open a new array. And we're going to provide the Samsung phone, the Apple phone, and the Oppo phone. Now, at the very least, our shop has three products for us to look at. And these products each have a name, a brand, and a price. So we could go even deeper. We could create a class brand and go that way, but I'm not going to do that for this example. We want to show adding these things to a basket, interacting with these things, actions, not just data representation. So far, if I import this, okay, so I'm going to export these. And I'm going to import them here. Okay. So I'm going to run this in the actual test file so we can console log some stuff. And let's take a look at the Samsung phone, and let's take a look at the phone shop. Just see what that actually translates to when we are in JavaScript land. Okay, so the first one you see is a product with a capital P. Its name is, or its brand is Samsung, name is phone, price 3,000. The shop has the currency, it has the three products. So far all we've done is make a really fancy object. Like, you could have done the same thing by saying, okay, well, phone shop equals an object, the currency is this, and the products is this, you know, like there's no value yet to this class over just making a normal object. And if I log both of these next to each other, so the only difference right now is that the example I just made doesn't get this nice little like annotation. But but that annotation is not much use to us as coders, right? It doesn't matter to us whether the console is able to see this. So what I'm going to show you next is why we don't just do this. What makes a class like powerful? And the key word in that situation is action. So a product, let's start with the product. So what are the things that you need to be able to do with a product? You need to be able to add to cart, right? And this is going to have to interact with local storage. So we will need our function. I'm actually going to leave that blank and do a bit more scaffolding. Before I'm going to write the code, I'm just going to scaffold and see if it makes sense to me before I go down a bad alley, because the shop could also have that responsibility. And I think that makes more sense. So we're going to start there instead. So the shop, let's just call this buy. And then this is going to be a product because we want to buy a product. So what happens when we, actually no, that doesn't make sense. Going back to add to basket, or add to cart. So add product to cart. We're going to import our save or our storage stuff. So import storage from storage. And then this function is going to get the basket. So we're going to say storage.load. Is that? What am I doing wrong? Yeah, there we go. Okay, I don't know what I was doing wrong last time. So we're going to say the existing basket or the existing cart contents is whatever is stored on this token. And then we can cart contents, append product, and then we can save that again. Cart contents, for which we need a key. Cart contents. So that should be a very simple way to add a product to the cart. It will allow you to add multiple products of the same type because it's not checking to see if there's an existing product in there already. And we need the opposite. We need a remove from cart function. And we also are going to have a product. I'm now thinking that it might be a good idea for each product to have an ID. Yeah, each product is going to have an ID. So we're actually going to say product ID here, and I'll come back to that once I've added the ID. So why do we need an ID? Because you could, in theory, have multiple products with all the same details. So you could have like 15 different product class instances that are all almost the same. So how do you know which one you actually want to remove? You need an ID of some sort, something that's going to be unique. So the quickest way, in my experience, to create an ID is to use date.now. If you want to, you can make that a string. And I'll show you what that does in the browser console. So date.now tells us how many milliseconds has there been since the 1st of January 1970, which means that every time we run it, not only are we going to get a different value, but we're going to get a value that has never been seen before, because it's never been now before now. So this is the numerical representation of now in relation to 1970, and that means that it's very useful for creating a quick, unique identifier. You can be sure that you're not going to get two products that have the same ID, because at the very least there's going to be a millisecond before each one's created. And if that's not the case, then you're very lucky. You might be processing something very light. If I wrap a string around, all I'm doing is the same thing, but I'm just saving it as a string, which is a bit more sort of maybe comfortable than using a number. And then you can also, let's see if I got this the right way around. No, I did not. B to A. If you want to, you can also base64 encode this so that you get something that kind of looks like an ID. There is also a crypto module, I think. Do we have that? Crypto.randomuid. That's probably the most robust and reliable way to do this. So that's what I'm going to use. This is just generating a unique ID. So every product is going to be given a unique ID, and that's going to be the ID that we're looking for when we're removing an item. So remove from cart, we have to do a very similar thing here. We have to get the existing cart contents, and then we are going to filter the cart contents. And for each product in the filter, we're going to assert that the product.id is not the provided product ID, because we want to remove everything apart from the matching product. So this is going to be our new cart contents. And then we can storage.save cart, new cart contents. This is not bug-free, just so you know. I'm not doing any checking in here, so I should really const existing product equals cart contents dot find product. So I should look for the look to see if that product already exists in the cart before I add it again, because like if it's or maybe that's just what quantity is. I'm going to treat that as quantity. So I'm going to let you add as many of the same product as you want, and then we can just we can call that quantity. That's fine. So we've got add to cart, we've got remove to cart. So what's the next stage? We've got to test these things. And we have this little testing zone over here. We have our phone shop, and we have our 3 items. So what I'm going to do is I'm going to start off with just the single item. And then I'm going to phone shop, add to cart, Apple phone. And then we will take a look at the state of phone shop. And we have an error, append, can it read? Okay, so, yes, okay, right. This is a great error. Very happy to see this error, because it's me being stupid, but it's got a nice solution to it. So, I tried to add in here, cart contents is null or undefined. then I tried to add something to it. So this is a problem. This cart local storage item doesn't necessarily mean I load the page for the. So we need to make sure that that the cart exists every time the shop is created. So that's a good thing to do in the constructor. So I'm going to say create cart is a new function. And inside that, we're going to storage dot save. And we're just going to create this with an empty array to begin with. It actually means that we could persist cart contents. So if we make cart contents an empty array by default, when you're creating your shop, new shop, US dollar, empty list of products, and then empty list of cart contents. So if you did have that data, you could reload whatever was in the cart at the point where you. I'm explaining this very badly. When you create the shop, it will go to local storage and see if there was already some stuff in the cart, and it will add it to your cart when the app is first created. So you don't have to there's no delay before you see your items. That's also going to be cart contents, and then that's going to be cart contents. Okay. So I think I've got everything I need now. Let's try that again. Cart contents is not a function at add to cart 25. So I'm pretty sure that's the problem we just solved. So I'm going to look in my application here. I see an empty array, which is what I'm expecting to see. Oh, let's just, okay. I'm going to check what this actually is, this cart contents, because I'm expecting an empty array, but that doesn't seem to be, that is an empty array. So why can't I append to it? Oh yeah, you're totally right. There we go. That was just me having a JavaScript 1 brain meltdown there. Okay, there we go. So we can push a single product, and let's do some more. Let's put the Oppo phone in as well. And that seems to be do I am I also, is my mind going crazy? Here we go. So in local storage, we have our Apple product and we have our Oppo product. So that is working, but I'm looking at the class here and I'm frustrated that I can't see what's in the cart here, right? The data is being stored over here, but that's kind of frustrating to me because I might be handling this object and I want to get that data. So do we duplicate the data? So coming back here, I want something called this.cart, but we're storing this data in local storage. So it would be wrong if I had, so in create cart, if I did this.cart equals cart contents, that would kind of solve the problem. But now I've got to update this every time. And whilst that's not the end of the world, it is broken a principle that's very important in software engineering. I have now created two sources of truth. What's in the cart? There's now two answers. There's what my class says is in the cart, and there's what local storage says is in my cart. And they are hopefully going to be the same, but hopefully is not really a word that we use in computer science. We prefer certainly and provably. So this is not the right way to go. This is going to cause me more problems than it's going to solve me. The way to do this is with one of my favorite bits of JavaScript in the whole world, which is a getter. So we are going to get the cart or cart contents, and this function, so we have to return something. In this case, we're going to return storage.load cart. So this is a function, but it doesn't behave like a function. And I'll show you what I mean by that. So we have our phone shop, and based on what I just wrote here, you might think that the way to get the cart is like that, but it's not. It's like this. So if I say console log cart, I'm going to see my two products there. This is incredibly magical. If like I'm not joking. This is like one of the most useful things in this programming language, because this is a dynamic value that's behaving like a static variable. So if I continue adding, if I add a bunch of these phones and then I log the same thing again, it updates. Okay, great. As in we don't have to keep track of the cart, it's just pulling the data from the right place for us. And then if we actually log the class itself, you can see this ... So cart is kind of grayed out, and then there's this brackets and a ... And the reason this happens is that the browser is saying, I will show you the value of this data when you click it, because it might be different, right? Okay, it's very hard to show without a timer. I'm going to do that again, and I'm going to do this. Okay, so I'm calling console log before adding all of these. And if this was just if that cart was just a variable, then it would say 2, right? It would say that there's 2 products, because that's the only products that have been added up till then. But it's not a variable, and so it gets updated. It knows that something has happened. So that is a getter. They're very, very useful. That's one of the reasons to be using a class, is if you have a source of data that is going to be fighting with your primary source of data, you can specify here is where it's coming from. We can also do the opposite. So we can also set the cart with cart contents, which will be an array or an empty array by default. So this one is kind of similar to this, in the sense that we're going to be doing that. But this means that, so just by adding those 3 lines of code, we have allowed ourselves to, like this one, we can just say, we have this .cart, and we want to add. Okay, so this is the spread operator for anyone who is curious about that with our product. So that's all the code we need now to add to the cart. Because when we assign to this, what we're really doing is running this function. And this function's job is to save whatever array gets passed in here. And so this is a sort of clever way of going through this whole process. When it comes to removing, we want to say this cart equals this cart.filter. So this has cut down the number of lines of code we need quite a lot, and it's storing all of the key data in local storage. We're making sure that we create the cart when we first create this class, and that's a decent implementation, but there's further that we can go. So another thing that you would use a getter for is total, right? What's the total value of all of the items in this cart? We can probably use reduce here, I suspect. So we have a big list of complicated objects, and we're not interested in every part of the data. We're just interested in the price data. So the word reduce, I like to think of the analogy that comes to mind when I'm trying to make sense of the reduce function is being a chef and having a saucepan full of some sort of sauce, maybe a gravy or something sweet, and you put it on a high heat and you let it boil down into something stickier and sweeter and stronger and more powerful. And that's called reduction. So that's what goes through my head when I think about reducing an array, is we have this big watery array full of data that we don't really care about, and we want to put it in the pan and cook it down until we've got one bit of caramel at the end. And that's the data we want. In this case, we want to cook away all of the name and brand information and just leave the total price of all of the products in the cart. So how do we do that? Well, we have this .cart. We know that's an array. The next thing to do would be to get rid of all of the product date. So we don't need that, right? Actually, we don't need any of that. We don't need the ID, we don't need the name and the brand. We just need the price. So inside this map, I'm going to say product, and I'm going to say product.price. I'm taking a list of products in an array, and I'm turning that into a list of prices with none of the other information about the products. Now to add them together, this is where we use reduce. So it is pretty confusing. And the syntax, like I don't quite know what it is about like accumulator and current and stuff like this that just doesn't quite ring true for me, but it is an issue. So if we're looking at the JS docs here. We've got previous value, current value, current index. And then there's a starting point. So how can we phrase this in our example? I think the best way to phrase this is total, and then current, right? Because we're going to be adding total to current. So for each loop, we're going to be it's a loop just like map is a loop, or just like for each is a loop, except instead of dealing with like one argument here, we're dealing with a lingering argument. This first argument is being built up over time, over the course of the loop. So if I take this and make a simple array, is that correct? Yeah, it is. Okay, good. So what have I done? For each, so it starts off with 1, and the total is 0. So it adds 1 to 0. Now we go to 2. The total is now 1, and the current value is now 2. So it adds 1 to 2. Now we go over here, and the total value is 3. The current value is 3, so we get 6. And now the total value is 6. The current value is 4. We add 6 to 4, and the bit of toffee in our pan is 10. We're doing that just for the prices, only for the prices, because we've mapped away the rest of the data. So we can just return the result of this reduce, and if we need to add some products. Okay, so now we have our currency, we have our products, only one of them. Why is that only one of them? Does my setter not work? I think I broke this in the process of doing all the fancy stuff. So set cart. So that can be, to start off with, that's fine. Excuse me for a second. Sorry about that. Okay, so I want to debug this, see what's going wrong and where. Oh, hello. Products 1. Okay, so it is coming through. they are coming into cart contents, and then they should be getting saved in local storage. Yeah, it is getting saved. Okay, so it's the setter is okay. The getter maybe is the thing that's not telling the truth. Can we do that? Is that allowed? Async get? No. Okay, it is working. All right. I don't really know. Oh, right, product. I'm looking at the wrong thing. Here we go. Yeah, you can see my brain is not quite recovered from the flu here. So, the products is just the products that are on sale in the shop. That is not the cart. So I was just looking at the wrong thing completely there. We do in fact have our cart object here, and we do in fact have our total. So this is being calculated if I add, so if I store this as a variable, so we've got temp1 is now a shortcut to our class, and I can add to cart a product, and it doesn't actually matter as long as I put a price. So if I put like a really high price in there. So now the total has been updated by that amount. So this is really, really useful for when you're working dynamically. Maybe you're dealing with something that's going to change and you want to always know that the data you're getting is up to date. This is a great way to do it. And just to round off this particular example, let's go back into the class, and we'll do get total, and we'll do get total formatted. And this is just going to be return this dot total. In fact, I think Norwegians like to format numbers in a strange way. Number get local number format. Is that a thing? No. Okay, so I want to format this number in local to locale string. There we go. No? Huh? Do I have to say the language here? I'm sure this is what I want. Oh, date. Number to locale string. Yeah, isn't that what I'm doing? Am I not doing that? Why? I don't know what I'm doing wrong here. There we go. Okay, so it has to be in a variable. Sure thing. JavaScript. I don't really know why that's the case, but who cares, to be honest. This dot total to look, I've now forgotten that locale string. Okay. So let's try that quickly. So we have total formatted. So that's looking a little bit better, at least for my browser in my language that I've selected. And I've got to look this up, but so do you put it at you put kr at the end? Is that how this works? Like if I say like 10 kr, that looks right. Yeah, that looks fine. I'm sure you can tell me in the comments if it's not the case. So in our formatted, we're going to add that. In fact, we're going to use this .currency. Okay, and I'm going to, in the example, change NOK to KR. And when we run this now, we have total, and we have total formatted with the currency code. So two types of data. One of them is more useful for, if you're calculating something, you're going to use the total value, but if you're displaying something, you're going to use the formatted value. So this is a very common problem that computer programmers have, is how do I represent the same data for a human and for a machine? This is one way to do that. Okay, so how are we doing in terms of our plan? I think that example does cover classes quite well. We have covered modular JS, although we will continue doing that because I only use modular JS. So when I'm doing things like this, anytime you see import or export, that means that modules are being used in some way. We did go through reduce. We also have at least an example of map and filter. So let's pull sort out and make that number 8 or whatever we're on. So we have promises, destructuring, and sorting. Okay. So let's continue with this class, and I will introduce promises to it. So the shop, so far it is keeping track of our basket or our cart and the cart total. But it might also need to do some API work here. So I might have a checkout function or an async checkout function. And when we check out, we are obviously going to be sending the contents of the cart to an API. So there's going to be something like this, awaiting fetch, and then we're going to have our API URL, whatever that is. Then we'll have our options, and we're probably going to be posting, I would imagine. So method is going to be post because we're creating something new. We're creating a new order. We're not updating something, in which case we would use put. We're certainly not deleting anything. So in this case, post makes the most sense as the method. We are going to have a body, and that body is going to be the contents of the cart. So we need to do a little bit of preparation there. We need to, well, we have this .cart, but we need to stringify that, because just like local storage, and for the same reason as local storage, an API request can only send information that is a string. The only way around that is by encoding a string. And this is not a rule. That's not a rule that someone decided once. that it would be fun if the only thing you can send over the internet is a string. That is a law of physics. That is not something that can be changed. Something we have to work around. So every string is really just a number, and every message you've ever sent in your life, every heartwarming love letter you've received has really just been a long number. And if you break that number, if you take a bit out of it in one place, none of it's going to make sense again. So even the things that we read and write is in computer land just a series of numbers that have been encoded for humans to understand them a little bit better. So we have to send it as a string. That's why we have this extra step to stringify the cart. And my my rule with variables is if I'm not going to refer to something more than once, I don't really think there's much point in creating a variable. So I could do this, and I know there are examples of me breaking my own rule, but I could say serialized body like that, or serialized cart. Maybe that's going to be clearer for the next developer who's going to work on this. So I'm going to leave it like that. Seems fine. So normally we would have something like this, right? And then we would return awaits response.json, assuming very optimistically that nothing's going to go wrong in this fetch request, and that whatever data we get back is going to be useful to wherever this was called. But I'm not doing this. This is how your checkout function might look, but we're not going to do that. Instead, I want this checkout function to pretend to save something on the API and then wait a little bit of time and then return something. So when we're talking about promises and asynchronous functions are the same thing. If I write, so I'm just going to leave this function empty for now, this checkout function. If I said new shop US whatever. If I said example.checkout, I could say await example.checkout, or I could say example.checkout.then. Both of these things ensure that the next action will happen after this is completed, so they perform the same task. If I write async example function, so you could structure it as example checkout, then go to order page, something like that. Or you could structure it as await example.checkout, and then do that. These two things are the same thing. I don't recommend using then unless you have to. And if you have to, you're in a bit of a strange situation. Like either someone is forcing you to, or you've boxed yourself into a corner where you don't have async available to you. So for example, I can't, if we go back to the testing file, I can't await checkout, or at least I should get an error for that. I guess I guess top level await is, oh yeah, I'm in a module. Okay, so that is actually that it does actually work. All right, well, if you weren't in a module, so I can show this if I'm going to create another file called example just for this point, and I'm going to say await fetch google.com. And then I'm going to ref that in here. Okay. It seems like top level await is fine. I thought that was not allowed. Okay, well, I mean, it sort of stands to my point that there's not really many situations where you have to use then instead of await. The reason that you use await is that we are dealing with a script, and our our file is called JavaScript. And as I said earlier, these analogies that the early computer scientists sort of came up with are not by accident. They tried to pick the best word to describe the concept. So when script was chosen as the name for a file full of code that runs, it was not an accident. The idea is that it is the same thing as a theater or a movie script. Character one. Oh, my spelling. Okay, we'll call him Bob. Bob, hey, how are you doing? John, yeah, I'm great, thanks. If we let's do another line. Did you see the big game last night? I'm not getting carried away with this, I promise. This is not going to be 3 hours of me living out some sort of weird fantasy. Yeah, an unbelievable display. Thing about Arsenal is they keep walking it in. If you start to switch these things around, it stops making sense. Now you have a gibberish conversation that only two mad people would have with each other. It's the same idea with scripting. Up at the top is the past, and down at the bottom is the future. And we progress line by line through the script from left to right, left to right, left to right. And that is the order that software is executed in. So this file, the first thing that gets executed is this line. Then this gets executed. Then this gets executed, right? It's sort of so straightforward that you might not have ever stopped to think about it. The problem with then is that it breaks that completely. If we have phone shop then and then like a function where we do something else, even something simple, hello, and now we have world down here. It's not that it's not that it won't print hello world in this situation. It's that we don't know whether it will print hello world or whether it will print world hello, because we have no idea. Oh, I'm actually meant to do checkout. Sorry. There we go. So we don't know how long this checkout process is going to take. And we do know that the JavaScript interpreter is going to keep going next line, 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 gets here. Okay, cool. You're going to do something in like 3 minutes. Next line, next line, next line, next line, world. And then only once this is resolved in 3 minutes time do we have hello come through. This is a big problem because it means that you can't look down a file and see chronologically what is going to happen. You have to suddenly pick this out as a new time context. This is going to happen at unknown o'clock. We don't have any idea when it's going to happen. And so this whole block is like sitting outside of the document. It's not the document, it's sitting outside of our script. It doesn't follow. It's like if you're writing your movie script and you had a character say like, hey, and then like in brackets, in 10 minutes time, this character will fall over, and then just continuing on with the rest of the script. It's like, why put that information here? Why not put it on line, 50 when he needs to fall over? So that's my slight rant about then versus await. My opinion, since they do the same thing, we'd much rather do this, take away this, and now it's really clear, or yeah, it's very clear what's going to happen. The order is clear. First this, and it will take an unknown number of seconds, then this, then this. There's no ambiguity. There's no sort of nothing to guess is the best way to put it. There are times, so the other side of that coin is that when I declare an async function, this is a function that returns a promise, which is a bit of a weird thing to get your head around. So if I return hello, and we look at the JS docs again, this function returns the promise of a string. If we take away async, it returns a string. We go back, it returns the promise of a string. Promise is another one of these words that was chosen carefully based on the real world equivalent. When I ask so let's say I am at a physical shop and I'm buying a loaf of bread, and the shopkeeper asks me for my money for the bread, and I say, oh, I have it, but it's at home. I'm going to go home and get it, and I'm going to bring it back for you. I've just made a promise to the shopkeeper for 16 Rand. If I had it in my pocket, I would just give it to him straight away. That's like the difference between a synchronous and an asynchronous function. So payment would be 16, right? 16 units of currency. The promised payment is also 16, but we have to wait for the promised payment. My money. We don't have to wait for this one, but we do have to wait for this one. Now, in reality, we don't have to wait very long. In this situation, we probably have to wait a period of time that is smaller than 1 millisecond, because there's nothing in this function that actually takes any time. So if we can actually test this. By setting a timer, and we can see that it took 3% of 1 millisecond. So that's not a long time to wait. But we can also test this one, and we get an even smaller number, right? That's half of a percentage of a millisecond. So we're dealing with very small periods of time here, but the point is that this is an unknown period of time. And the reason it might be unknown is because if we're, instead of returning something, if we're awaiting a fetch, there's a lot going on. Your internet could be slow, the server could be under heavy load. There's a lot of external factors that could slow down this request. And so we need to be able to wait indefinitely for it. So that's the purpose of a promise, is to shift something out of time. Whereas usually, most things we're doing are instantaneous. Anytime we're using async, we are returning a promise. And this can be quite useful if you want to set a function that acts like a timer. So if we have timeout, and we're going to have the number of seconds, we can return a new promise. And a promise has two arguments, resolve and reject. And the idea with resolve and reject, the idea is that not everything is going to go successfully, right? If you're doing an API call, your API call might fail, or it might return a status that you don't like. So that's what reject is for. Resolve is for when everything has gone well, and so if you're fetching data from an API, the response comes back, it's okay, you have your array of items, so you resolve those items, and that's the end of your promise. Everything's tied up in a bow. If you can't resolve it because something's gone wrong, that's when reject comes in. In this case, I don't actually need reject because this function can't fail, because I'm just going to say resolve. Oh, no, I'm not. Set timeout. There we go. So I'm going to resolve the promise after a given number of seconds. That's all this function is designed to do. And I'm actually going to test this in the browser console. So in theory, if I have a test function, I'm going to await timeout for 1 second, and then I'm going to console log time's up. Okay. Maybe I'm going to change my test function so I can pass in seconds here. Seconds. And let's put we can also put a console timer in there just to check how accurate it is. So console.time and then console time end. And now I can test 3 seconds or 3 seconds, yeah, 3 seconds. And there we go. Time's up, and it was um, accurate to like 10 milliseconds. Let's try it again. Okay, so it seems like it's reliably about 10 milliseconds out. But that's fine. I can live with that kind of error rate. If I was a back-end developer, I would not tolerate that kind of thing at all, but I'm a front-end developer, so 10 milliseconds seems like nothing to me. All right, so I'm going to cut that function, and I'm going to take it back to my service. Where has that gone? So I don't need that. API service, here we go. So inside this big class, in fact, I'm going to take a second to refactor this because I don't like this. So classes having a capital letter tend to also have a capital letter in their file name. And we have two, we have shop and we have product. And I'm just going to split these into their own files. Okay, that's a bit better. And then here I'm going to export defaults, and I'm going to have shop, and I'm going to have product in here. In fact, these should also be export defaults. If you're only exporting like one big thing from a file, it's quite nice to use a default. If you're exporting lots of stuff from a file, then you won't really want to use that. But classes are like important, you know, they're big, important things that there should only be one of. So I like to give them that extra special treatment with a default import. Okay, so importing shop, importing product. So we've got our index file, which is something we can import if we need these things later on. And in the process of doing that, I deleted this from my clipboard. So there we go. All right. So I check out. I'm going to paste this in here. I'm going to call it wait or delay. And then I'm going to add a callback function. Am I going to do that? No, I'm not. I'm just going to leave it as it is. Okay, so we've got the delay function. And what I'm going to use this delay function for is to like simulate a API response. So when you check out, where you would usually have const response equals await fetch, I'm not going to do that. Instead, I'm just going to say delay 1.5 seconds or delay 3 seconds, and then return checkout completed. I mean, we would probably get an object back, right, from the API. So it's going to say something like message, checkout success, and order value, and that's going to be the total, but we want to save a static version of the total. order value, or let's use the formatted, this dot total formatted, that's better. So message, checkout success, order value, total, and then let's say order ID, and we can use the crypto dot whatever to create a fake order ID. We also want to clear the cart. So I'm going to say this is the result. Once we've got the result, I'm a bit worried about this changing, but we'll see. We'll see if that happens. Then we want to set the cart to nothing, right? Clear the cart, and then we're going to return the result. So let's try that out. Okay, so we're going to load all of the products as products. Then we're going to add to what's going on there? Phone shop dot add to cart. Okay. Right. Add two products, and then we're going to checkout result, let's call that, await phone shop dot checkout. And let us log the phone shop here early on. My theory is that the price is going to be wrong, that it's going to say 0 for the price, or it may even say undefined for the price, but we'll see, or not a number, we'll see in a second. Rights imports are wrong, so because I changed the way this works, I have to change this up slightly. So I changed this to a default import. If I go to service index, this is the default import instead of a module like this. So I'm going to call this Ecommerce. And then we have ecommerce.product and ecommerce.shop. Okay. So that doesn't look like it's working, as in it looks like it's happening too quickly. I'm going to make this like really long. Yeah, I don't think that's working. So the shop is coming through. Here we go. Reduce of empty array with no initial value, I think is what it wants to say there. That was something when I was doing the reduce, I skipped a argument, and I think I'm just going to check MDN quick here. So with reduce, you have to say where it starts. Okay, right, so it's a second argument. So I've got this is the first argument, this is the second argument here. So in this case, because we're dealing with numbers, I need to tell reduce that the operation should start at 0. Otherwise, it doesn't know which type of data. Like you could be doing a string reduce, or you could be doing lots of other things apart from. You could be doing an array reduced, where you're building an array, or what have you. So that was a little oversight on my part. I don't think my wait function is working though. Oh, okay. Why is it not working? What am I trying to demonstrate here? Oh, wait. I'm going to say that I did that on purpose, but I did not do that on purpose. Right, so when we run now, we get the shop, then we're waiting for quite a long time. I think I set it to 100 seconds, so maybe we want to change that. Waiting for 3 seconds, and then our message comes through. So that's kind of simulating the behavior you would get from an API. We could go further, we could create a class called order, call this order.js, export class order. Constructor is going to be, it'll be the products, it'll be what's relevant in an order. They need an ID, needs a username, I guess. So you would need products and you'd need username or user ID. And that's probably it. This dot products equals products. This dot user ID equals user ID. And then we can steal the same totals from this, except we're going to change that to products. What else do we want from the order? We need to give it an ID in the same way that we gave a product an ID, like that. And it needs a date, so this dot created maybe equals new date, because that's going to give us the date for right now. And maybe we have this dot status equals pending. Some things that we might have as a function would be change status. So we've got our order. And we could say at this point that order equals new order. And we're going to pass this dot cart as the products. I'm going to use my name and return the order. So we have our delay, and now we get a nice detailed, rich object with all of the products that have been ordered, the total. Nice, okay. Didn't think about that, but there we go. There's no, this user ID, you can, if you want to, you can replace user ID with a new, you can have a user class, export class user, and they're going to have a name and they'll have an ID. And instead of storing just an ID in your order, you can store a real user. And when we go back here to shop and checkout, we can then say new user and put me. And do it all again, run that test. And our order object now has a rich user object nested inside it. It has our products. It has all of this data. So this hopefully has given you an idea of using classes practically. I think the last thing, okay, so we haven't done destructuring. Where's the plan? Here. We've now talked about promises. We haven't done any destructuring yet, and we haven't done any sorting, but that's fine. I think I've got one more trick up my sleeve when it comes to classes. So far the classes we've got are very they're handling pure data. They are, if we go back to my app is sad because it's just got all of this test static data. It's not real. But I have my template. So I have this card product template that I've already kind of sketched out, and I'm happy with the design of it. So I'm going to copy the HTML for that. And I'm going to create a new file or a new folder. It's going to be called templates, and this is going to be called product. The following requires a disclaimer. It's not a great idea to store HTML in JavaScript. But if you're going to do it, there are certain ways that are better than other ways. So this file is just containing a template at the moment. And I'm going to import it elsewhere and manipulate it. I can cut quite a lot out, so I could cut source and I could cut all the details. But what I'm trying to do is show a quick, in fact, do I need to put it in a template tag? Yeah, I kind of do. So I'm just going to wrap this in a template tag just to make it very obvious. Okay, so this is our product HTML. So far, the product class is kind of just for storing information. So I'm going to add a render function. And the render function's job is to take the data contained in this class and to show it in HTML. So there's actually two functions really. There's one to prepare the HTML string, and then there's one to insert the HTML string to the correct place. So this can be a getter, this template, and the idea here is that we are going to substitute values in here. So one way to do this, in fact, I think this is probably going to end up being the easiest way. So let's just not overcomplicate things and do it the straightforward way for now. So the template is just going to return this string. Yeah. So it's just going to return this HTML string, and then we have an opportunity to say, okay, well, that's going to be this dot image, which we don't actually have in the constructor, so we need to add that. And maybe I'm going to pick a example image, use the timeless picture of dog. So if an image isn't provided, there's going to be a backup, there's going to be a placeholder image. And we are going to change the title to be this dot name, and we're going to use the ID here. So at data ID equals this dot ID, and the link is probably going to be something like product with a query string ID equals, and then the ID. What else do we have to change? The features are static. We've got a brand. So let's do name by brand. Okay, so that's the template function, and the template function doesn't actually render anything. It just prepares the HTML and gets it all ready. The render function needs to put it in the HTML, but the question is, where? Where does it go in the document? Do we just put it anywhere, or are we trying to put it in a specific location? So I'm going to set the parent by default to be document body. So if you use this function without specifying the parent, it will render directly into the document body. And all we're going to say here is parent inner HTML. No, we're not. We're going to do this nicely. We're going to say parser equals new DOM parser. So this is not necessarily something you will have seen in your lessons. This is one of my pets, one of my JavaScript pets. I like DOM parser a lot. It does what inner HTML does, but it's for people who have commitment issues. So instead of just shotgunning your string straight into the document and hoping for the best, with DOM parser you attempt to turn a string into real HTML, and it gives you a chance to catch the error if there's this problem with the HTML. So it's a little bit like more mature and safer than in HTML. And the other nice thing is that it allows you to like set listeners and interact with the HTML before you render it. So if you've ever been in a situation with inner HTML where you're trying to set an event listener to like remove an item, but you can't set the event listener because the item doesn't exist because you haven't created it yet. And then when you do create it, you have to query selector for it again. And so you have to add a special ID to that button. And it's not how it's meant to be. You're meant to do all that stuff before you render, not afterwards. So DOM parser gives us an opportunity to act on the HTML before we render it. So how do we do that? Well, we use this DOM parser, and then we say parser.parse from string. Then we're going to use our template. So that's this .template. And we have to specify which type of encoding it is, which is HTML text. And the result of this method will be a real div. So this is going to be the element, and we can append that element directly into the parent. If we wanted to, at this point, we could say element add event listener click console.log, right? And then append it, and we can see how that works just now. So this is we've got the data side, we've got the markup or the presentation side, and then we have a function to actually insert that presentation into the document. So let's try and demo that. So we've got our phone shop, and we've got our products from our phone shop. So for each of the products, we want to render those, but we don't just want to render them anywhere. We want to render them into the right place. So I'm going to just quickly remind myself where that is. So I'm gonna call this products. So we know that we can get that with a query selector. And now we can say phone shop.products.map, or we could do for each actually. For each, nope. For each product, sure. How's my spelling and brain? For each product.render. And we need to pass the products container in there. And that looks fine, but I'll probably have an error anyway. Yep. Okay, so the first error is just because this script doesn't exist anymore, this one. The second error is saying cannot execute append. Okay, yep, right. So what I forgot is that when you, so this is, I misnamed element, because if you look at the JS docs and the return value of the JS docs, it is a document, it is not an element. So I should have called this doc, not element, and that adds an extra step where I have to say element equals doc.query selector, and I'm looking for a dot product. So I've got it effectively. This is like a whole HTML file, but it only contains this. And I'm not trying to insert the whole file because you can't have two files inside one another. So I'm just grabbing the product out and using that instead. And there we go. There's our oh, I forgot to take the one second. I need to go get. So what I didn't take the column, this stuff here, so it's not going to be laid out nicely. It's very important to me. Okay, and that was products, and we got rid of that also. So this actually needs a little adjustment just to make it look nice. Haven't really changed the functionality there. All right. Um, so now we have our three products from our bus, from our shopping, from our shop. We have three dog photos because that's the placeholder image, and I didn't specify an image when I created my products here. So if I could be a little bit less lazy and add those. Now we have three different images: phone by Samsung, phone by Apple, phone by Oppo. Um, if we add a new product, it's very easy. We can say cowboy hat, made by a cowboy, I guess. That's how it works, I think. Oh yeah, right, I didn't add that to the list of products there. And then we have our hat by cowboy. We have this button, add to cart. Currently it doesn't do anything. Where would the responsibility for that lie? We've got this button here. So I would set that event listener before it's actually rendered. So you see here I have the click event listener, and if I click on one of these I get just an event readout. So I'm going to change that slightly, and I'm going to get the button or the add to cart button to be more specific, and I'm going to say element.querySelector, and I'm looking for a button with the data cart equals add attribute. So I've got my add to cart button, add event listener, click, and we are going to, oh, now we have a problem. How do I access the shop from here? I don't know. We would need to have a variable containing that shop here. Yeah, I think I've got myself stuck at this point because I can't think of a way to actually get that function in scope. The only ways I can think of doing it are not, they're like kind of hacks or counter patterns. Oh, I know. Maybe we just include it as an argument. So you have to include the shop with the render function. It's a bit, it's not great, but it's the quickest way to solve the problem I'm in right now. So let's go with that. Add to cart. except I need to, this is an event. And we're going to add this. So when you click on the button, it's going to add this to the shop's cart. And the only other change we need to make is in when we're setting up our products, or sorry, when we're rendering our products, we need to include that phone shop in here. It's not great. I don't really like it. That's a bit ugly to me. I think there would be a way of restructuring this to to avoid that, but I've sort of boxed myself into this corner, so there we go. And we need some code to like show this as well. So add to cart. I'm just going to log this.cart whenever anything is added. Okay. One item in the cart. Two items in the cart. Three items in the cart. So on and so forth. And if we log just this, when we do this, add to cart, add to cart, add to cart, and we can check and say, okay, there's three items, here's the total value. So this is meant to be, I mean, you can obviously change you would want to change the state of the button itself to show that you've added it to the cart. If you click it again, you'd want to remove that same product from the cart, and so on and so forth. There's lots more development to be done around this concept. But this is a classy way to do things. The only problem is when you are mixing classes, you need to make sure that you have the right data to hand, the right class to hand. But yeah, I think I'm going to cap off with destructuring. I'm kind of surprised that I didn't use destructuring at all naturally in any of these examples. That's what I was actually hoping to do, was just stumble upon a good way to to show that. So I think I'm just going to show that in this main file. Actually, we can use this data. So there are there's two different types of destructuring, and there are sort of maybe like 4 or 6 different times when you might want to use it. So let's say we've got our Samsung phone, and we're in a situation where we only need, or let's write a function. So we have a function, and it's called brand evaluator, and it accepts a product as an input, and it takes the product brand and let's make a switch, product brand, case, Apple. Actually, let's do lowercase as well, because that's going to make life easier. To lower case. So case Apple, return, you are cool, well done. Case, what else have we got here? Samsung, return, I can't think of a stereotype for you. Case Oppo, return evil 5G. Okay. And then maybe we'll have a default. This is not a phone. So this is just going to look at the, it's going to look at your phone, it's going to give you an opinion. So if we console log brand evaluator and we give it the cowboy hat, it should tell us that that's not a, did that work? Undefined. Oh, rights return. There we go. This is not a phone, right? Change it to Samsung phone. Change it to Apple phone. All right, so fairly simple. These things quite useful for like RPG type games, simple RPGs. The reason I've set up this structure is because in this case, we're accepting the product as our input, but we don't actually care about the rest of the data. We just care about the brand. So instead of accepting the whole product, we can destructure the brand property. So we're just, so these brackets means like it's the equivalent of these brackets are the same as these brackets, except it's like in reverse. We're asking for just this from inside the object, not the whole object. So we don't have to change this. This still works exactly the same. And if we want access to the phone details, we can do that too. We're not using them in this case, but we could say phone details. And if we look at this, it's everything apart from the brand. The ID, the image, the name, and the price. But the brand has been separated. So we're choosing to pick out one property from the object that's very special and very useful to us. And maybe these things are also useful, but they can stay in an object. The same can be done for an array. So let's write a function decide winners, participants, and this is going to be an array of participants. This is going to be a very simple function. We're going to say winner, second place, third place, losers. And then we're going to return winner. Or maybe we'll return these three. And this is taken an array, so if we use this and we have Bob, Sally, Susan, and Terence, or runners, decide winners, runners, and let's log that. So here we can see the winner is Bob, second place is Sally, third place is Susan, and we don't even have any mention of Terence because he's a loser and he's not included in this function. Many uses for this. Both array and object destructuring are really useful, especially when you get to JS frameworks later on. It is crucial. You actually can't not know it. But it's not necessarily something that we're using all the time. So it's not like it's not. I did have to kind of think of an example to show you, whereas most of these examples, like all of the modular stuff, it just is so natural to me that I don't even have to think of an example for it because it's how I write already. But with destructuring, it will crop up less frequently, but when it does crop up, you will really appreciate the fact that it is possible. It's sort of like the cousin or it's the sibling of the spread operator. So if you have numbers equals 1, 2, 3, and more numbers equals 4, 5, 5, 6, const all the numbers equals spread numbers spread more numbers, and that will combine these two arrays. This is like the kind of sibling or the cousin of destructuring. This is like constructuring, if that is a word, which is not. All right, well, I think we've covered everything. Sort, sorry, I think sort's just going to have to go for another day.